Hello and welcome to our talk about how to easily build healthy and reliable web apps using metrics and tracing. Short introduction on who we are. So today I'm joined by Thorsten, who's a software developer at AOE, where he's writing Go for more than 3 years. He's specialized in all things related to e-commerce and loves to share his knowledge with other colleagues and developers.
And with me is my colleague Carsten, who has his origins in the PHP world and started with Go about 2 years ago.
So today's agenda will be about the challenges we face when developing and operating modern web applications. We then talk about the opencencus library, which offers potential solutions for those challenges, which will be then followed by the live coding, which will be the main part of our talk, where we use the Flamingo web framework to write an application from scratch and add some traces and metrics. Afterwards, we have some time for questions and answers. So once upon a time, life was simple and web applications were just static HTML pages with only basic information. Users were usually happy if there was a web page at all and if it was reachable. If we fast forward to today, users expect applications to be always available and respond within a glimpse of a second. So the needs of our customers and the users grew over time, and so did the complexity of the applications. Besides that, there are business requirements like SLAs guaranteeing a certain uptime, and when it comes to the microservice architecture, there are additional challenges. For example, if you have a complex workflow that is orchestrated through a series of microservices, each of those interactions is a potential point of failure. So in the end, we and our customers want to avoid outages or at least predict them as early as possible. Therefore, we must ensure that our applications are healthy at all time. To do so, we need to collect and interpret data at best in real time, and therefore monitoring is key. But that is more than just logging. Health checks are going already in the right direction, so they at least tell us if part of our application is working or not. But due to the complexity of the applications, they're usually not just up or down, and we need more insights that are offered by metrics. So what is a metric, or what are metrics? So a metric is a measure of software or business characteristics which are quantifiable or countable. And it's important to emphasize the word quantifiable, since a useful metric needs to be concrete. For example, if you're in one of your reviews and your product owner says, wow, that new microservice responds super fast, then that's obviously nice to hear, but not measurable. But if you would say instead, oh, okay, the service responds on average with 20 milliseconds, then that's something that you can measure and count. We usually distinguish between different kinds of metrics. So the first or the most important one, and that is also what we tackle later in the live coding, is or are the application metrics that are highly depending on your application or your business. For example, if you're running a web shop, something like the number of started and finished checkouts would be worth looking at, so that you can early detect if, for example, the payment step in the checkout doesn't work, and so nobody finishes or can finish his checkout. Then there are obviously vendor metrics that are specific for the language or framework you're using. For our case, Go, for example, the Go routine count is interesting, or the allocated memory. And obviously our applications need to run somewhere, and to have also infrastructure related data, we need platform metrics that are showing how many storage is used or how many requests are coming in. And that's especially important if you have an application that is sharing its host with another application. Since we have a variety of stuff that we want to track and different styles, there are also different types of metrics. So the most simple one is the counter, which is just a value that is increased, for example, the started checkouts. Then we have the gauge, which can go up and down, like memory usage. And then for stuff like latency, we have the histogram, which puts these latency values into buckets. Now we talked about the definitions and types of metrics, and to give you a quick look at how that looks in the wild, we simply grabbed output from one of our application's metrics endpoint. And as you can see here, there are different kinds of metrics. For example, this Flamingo ZEP logs is a counter, which shows us how many error logs there were, and we have the Go routine count, but that's really machine readable and not human friendly. So there is tooling to visualize those metrics, and one of them is Grafana, and you can simply build out of those metrics a nice looking dashboard, and you have always you always see at a glimpse is the service healthy or not.
Yeah, predicting and preventing outages is the first step, but it's not the only thing that bother our users. They want also high-performant apps. So how can we find a bottleneck in our performance? And as you guess, it's all about collecting and interpret data again. So at first, of course, we can use our metrics and interpret them in a meaningful way to find our bottlenecks. And the second thing is, and this is more important, to know exactly what is done in detail during a request in our complete infrastructure and in all details in our app. And that is what we call tracing. So it's understanding the path of a request as it is traversing through the parts of your application and even your complete infrastructure. Let's have a look at common wording here. A trace is what we call a complete record of the request. And it consists of several spans, and the span represents single operation in what detail level you ever want. A span itself can contain subspans to go more in detail here. And yeah, all are connected via the trace ID. So the whole data we collect here is building a tree, and the triplet trace ID, span ID, parent ID defines the exact position of a span in that tree. And this triplet we call the span context. And in Go, the span context is normally passed down via the standard context. If you want to trace between microservices, we have to pass the span context via the protocol headers, and the next service can then extract it and normally opens a new subspan. And yeah, the goal is to visualize this data. This can be done with tools, for example, with Jaeger. And as you can see here, we have an incoming request and all details, and even the switch to another backend service with the color switch, which is also tracing his details. Yeah, and let's finally have a look at the standard which is used here to collect the data. It's opencencus. It says about itself, it is a set of libraries for various languages that allow you to collect application metrics and distributed traces, then transfer the data to a backend of your choice in real time. This data can be analyzed by developers and admins to understand the health of the application and debug problems. Opencencus originates from Google and is open source. And it's not the only standard. There are more of this, and OpenTelemetry will be the successor of these standards. So it's a merge of open tracing, opencencus. It is currently in beta, so for this talk we still stick to opencencus, and yeah, the main concepts you see will be, of course, the same then in OpenTelemetry. Yeah, and now it's time for coding. So what do we code? Let's code something simple. We want to create a simple web application where the user can collect articles from the Go blog for a later reading session. We split up in two sections. At first, we really start from scratch and build a simple controller with a basic setup. Then we fast forward all the diligence work and continue with adding a health check, matrix, and tracing to our app. To not do everything by ourselves, we use a framework. There are plenty of web frameworks out there. We decided to use Flamingo because it has a nice modular approach. where we can plug in and plug out functionality, and it comes with an opencencus module, which wraps the library in a nice and usable way. So let's start with the coding part.
Since we are starting a new project, we obviously use Go modules, quickly initialize that. And since we are using the Flamingo framework, we require that as an only dependency. And then we can head over to the IDE, I guess.
Yes. So let's enable the modules integration and start with Flamingo.
And every Flamingo application starts with the same function. So we tell Flamingo to create an application. And since we don't have any modules at the current moment, we provide that with nil.
Yeah, and that's already an app. So let's see what happens now. So as we see, Flamingo is just a COPA command, and it's possible to register subcommands as we like, and there's already one to start the server. So let's use this.
And what we can already see here is that without configuring anything, we have already zap logging out of the box. And yeah, the server is now running, and we can visit the web page.
Yeah, let's see what we see in the browser.
It's probably on the other screen.
There it is. And as we see, we get a 404 because we have implemented nothing so far. Yeah, so let's start implementing the first Hello controller.
And since in Flamingo everything is basically a module, we start by creating a new module. And to implement the module interface, you only need to, you basically start a new struct and need to implement a single function that is called config or configure. And we leave it for now empty since we don't need to configure anything. And this new module can now be loaded inside the main Go. So we will provide here a list of Dingo modules, and one of that will be then our new app module.
Yeah, so we have a module, but it's not doing anything. So let's create a controller. And yeah, let's pretend we're doing domain-driven design and create it in interfaces. Let's call it home.
Yeah, and we start here with a struct again. And since Flamingo uses the request response pattern, we also need a responder here to render a response then in the end. And since the responder needs to come from somewhere, Flamingo offers the inject function to, so Flamingo will then take care of providing us with this responder. So we type it in here and assign then the variable.
Comma is missing.
Cool, so now we have our responder, and what is now missing is the single action. So we will quickly define that.
Yeah, let's call it a home action. Action always get the context, which we will later need for our matrix and tracing. And it gets the incoming request, of course. And returns a web result. So, what do we want to do? Let's just render a simple template using our responder. Need a template name called index, And we have the possibility to pass template variables, which we don't have for now. So rendering a template means we need a template engine. Flamingo has a wrapper module to use Go templates, so we just include this. And yeah, the template itself. Let's create a templates directory and some index HTML file. And yeah, let me just paste something here so we don't have to type HTML.
Cool. And now we have basically, we created a module, we added a controller, we added the Go templating module and rendered this template now. What is obviously missing is the routing part. So currently no routes are pointing to our home action. Therefore we create a separate struct, which obviously needs the home controller to then call the action of it. And the routes struct needs to implement the router interface then. And here we also use this Flamingo pattern where we let us inject the home controller. And then what's missing is now the routes function, where we then add the routes.
So the routes function just gets passed the registry, which we then can use to register our routes. So at first, yeah, let's serve it on slash, give it a name, let's call it home again, and then register the handler for our home. Yeah, for get only, and we want our home controller, home action, to respond to this.
So now we have the routing part finished, but we need to tell Flamingo that our module comes with routes. So we quickly do that in the configure function here. And that's it.
Yeah, so let's serve again. And look what we see. It's our template.
Cool. Then now we can fast forward a little bit because now we build our application from scratch. We will now implement the actual reading list logic and add a template that is more styled. And we can now quickly run the code again and give you an overview of how the application looks now after we did some diligence work.
Yeah, let me run this from the IDE from now on.
So here's now the reading list. Currently there aren't any articles on our list. We have the option to hit the articles menu to see all the block entries from Golang. And this is using an third-party or an external service we created where we translate the Golang block entries to JSON objects and are fetching them from here. And obviously we can add an article to our reading list, and when we head then back to the reading list, it is saved there. So to know if the application behaves healthy or is healthy, we can start by adding a health check. And the Flamingo core provides a module for that as well. So we just switch to our main function and add the health check module here. And this will then do a number of things that we see when we start Flamingo again. So as you can see here now, there is a separate port opened up, which is called system endpoint. And we, by adding this module, we see that there are 2 new routes added. That's for one, the ping endpoint and the health check endpoint. And we can obviously open that up in the browser. And it will just return an HTTP status 200 since we don't have any health checks provided. Yeah, You can implement those by implementing an interface, and we fast forward that step, and we basically added a health check for the third-party service that is parsing the Golang block.
Yeah, it's just a new module which is inserted in the main Go again, and it does a simple ping to our block service to see if it's there. So if we recompile, we should then see our health check here in the JSON.
So the health check is a good starting point, as previously mentioned. So at least we are seeing if the block parsing service is available or not, but it doesn't give us insight on how fast the performance of our application or that service is. And so let's try and add some metrics for that using the opencencus library. Flamingo wraps the library itself and comes with some default config, so we don't need to worry about setting up any exporters and stuff. So it's enough to add the module here again, and then we can head over somewhere and add some metrics.
Yeah, the module is just clicking on the system endpoint with a new route matrix. So let's write a metric. Let's write a simple one for the start. We want to count the added articles of our article list. So go to the list where the add article is. When we add one, we want to count one up. At first, we have to define a variable which contains the value, of course. The name doesn't matter. Call it stat. And it has to be an integer, giving it a nice name. Reading list, articles, metric, amount. And yeah, for the documentation, we can add a description. Amount of added articles, and then we need a unit. And we are just counting here, so let's say it's dimensionless. And yeah, that's our variable. We now have to register it for opencencus. This can be done in an init function. Say it is for the view. Yeah, to not confuse ourselves, take exact the same name. And yeah, give our variable, and we have to define the type. So this one is a counter.
Since we are only counting up and have not up and down.
Yeah, and we assume no error is happening here. Yeah, now we have just to measure our value. So if we have successfully added an article, let's just record with our context and a measurement of 1 in our case. We could measure multiple at the same time, but here we had one article, so we measure 1. And that's it. That's our metric and all we have to do for it. Let's, before we show it, let's quickly add another metric by fast forwarding. We want to measure the response time of our external service. And yeah, now let's reserve.
Then we can have a look at the metrics endpoint. So we see this mission countable part. In our case, Flamingo is coming with a lot of built-in metrics and also vendor-specific stuff like the Go routing count. And to see this metric, we obviously need to add some article, and we should then see our reading list articles amount. So at the end, we see that our counter is now set at 1 since Thorsten added 1 article to the list. And below that, we also see like a histogram, which we added on the for fast forwarding. So the block response times are now also there. And as we told you earlier, this is just more machine readable, and we prepared a Grafana dashboard showing all these metrics and all these vendor metrics in a nice way. So we quickly have a look at that. And that's also something you want to maybe have in your workspace or for your team, so that everybody can directly see all these metrics in a nice way. For now, we in the right bottom corner, we see the articles added to the list. That is one. Maybe that is over the day it decreases to 0, and that could be in something broken with your reading list, or it's just that nobody visits the application.
Yeah, and these metrics on the top are all coming by Flamingo standard. So by just including the opencencus module, you already have these ones. And for the response time, we decided to display the 95% quantile, so we can see if we got a performance issue here. So let me just call the articles page for a couple of times and see if we get a nice graph here. Which we don't yet. Let's add some articles. There the graph is coming.
Yeah, slowly but steadily. Maybe you change to the last 30 minutes, so maybe to the last 5 minutes. And so we see the data in real time. For example, we have now 5 articles in the list. We see the memory usage, and we also see the API response times. So as you can see in the graph down below, we have the different endpoints that we are consuming, and they respond with a certain time span. That's cool to get like in general overview and quickly see this different characteristics of the application. But now let's assume, for example, that the response times of our application suddenly increase over time, and we want to have a look why that's so. And that's where tracing comes in, and opencencus offers that out of the box. So maybe let's add some traces to our application to see what really is happening during a request.
Yeah, and adding tracing is even easier than adding a metric. So let's add a tracing to our well-known home controller. And as said, the span context comes in with the goal context. So we need just to start a new span here, giving in the context and a name. So let's call it app controller home, and that's it. The start span returns a new context for us containing the new span ID and the span itself, of course. So when we finished with tracing, we have to close the span. This is normally done by a defer. So we can just say span end, and that's all. This is all we need for tracing, and the main work is to implement these 2 lines on each detail level we want to have to. So let me fast forward this and add these 2 lines to each controller and to each function, for example, inside this repository load and so on. And if we reserve now, we should get a nice tracing.
Important to have that all working is obviously to have the context always available. So rule of thumb is that all the functions get the context from the outside, so tracing is possible inside of those. And we can just simply hit the articles page, and there should be plenty of traces. We have a local Jaeger up and running and can then see those traces.
Yeah, and there is our article call. And we see all the details. Flamingo is receiving the request, is matching it to a controller, calls the controller calls our blog service. Then we have finally the HTTP GET call. And the service is answering, and because it's also implementing tracing, we see even the details of this service here.
Yeah.
And yeah, when it comes back, Flamingo takes over the response and renders the template.
So we can then see that currently the most of the time of our request is spent in the external PHP-based service, where all articles are getting fetched and parsed from the HTML to a JSON format. And so we could optimize stuff here, or we could cache the response in Flamingo. And that's a really detailed insight. So if we have the challenge that our application or some of the requests in our application are running slow, we can really dig into there and have really detailed time measurements. Where is this time spent? And that's only happening by adding 2 lines of code in those functions. And that's really awesome, I guess.
Yeah, and that's all we have for today. So thank you for listening. All the code you just saw is public available in my GitHub repository. You see the link here. It contains also this local setup for Grafana and Jaeger.
So you can start right off the box and play around with that on your local environment. And we hope we could give you a good insight how easy it is to integrate metrics and tracing, because it comes down to 2 or 3 lines of code. And this really ensures the healthy operation of your application. Both topics would certainly be suitable for a separate talk. Especially the tooling around pulling those metrics and visualizing them in Grafana or in Jaeger was not part of this talk. But like many things, metrics and tracing are also empirical values. So, for example, with every new incident we face, we find out that a certain metric is missing or a service isn't provided with tracing yet. And nevertheless, the visualization of all that data, especially as a Grafana dashboard, has become really indispensable for us in order to detect problems as early as latest or staging. So it's important to have all these metrics and tracing also on all your environments, so you can easily detect problems that were introduced in an early release. Feel free to reach us on Twitter if you have any questions, or ask them in the chat or via voice. And you can also have a look at Flamingo, and that would be it from us. Thanks for listening.